squared minus 2x. The derivative is what, Mr. Hummer, I guess?
X minus 2.
X minus 2. Got it? Everybody happy with that? All right. And then if I do y equals 1/2 x squared minus 2x plus 1, the derivative of that would be?
X minus 2.
X minus 2. Now, are these different equations?
Yeah.
What's different about them?
There's plus 1.
Which is a constant, right?
Yeah.
So remember, we take the derivative, we lose the constant. So if we were to integrate backwards, the constant we'd have to take care of the constant, and these two derivatives could be two different answers for original functions, depending on where we started, right? Okay. Now moving forward, let's pretend for a moment, you and me, Hummer. Let's pretend I don't know how to do that. I don't know how to go backwards to get the original function. There's a way I can get a picture of what the original function looks like. This is how I do it. I set up myself a bit of graph paper. Yeah, set myself a bit of graph paper. And I do what's called a slope field. I put little dots all over the place. These little dots. Put little dots all over the place.
Do we have to do this every single time?
Yes, sir.
That's insane.
Although they gave you the dots, so you're okay. You really don't have to draw very many dots at all. That's not on you to draw them. Okay, so I want to look at this pretty picture. I want to figure out what this graph would look like. So how am I going to do that? Well, I have slope information, right?
Yeah.
On our premise, I only know slope. So, pause a moment. What is the slope at the point 0, 0? Mr. Hummer, look at your derivative. What is the slope at the point x equals 0, y equals 0?
Wait, what derivative?
The derivative you told me about.
Oh, x minus 2.
The underline said, look at this derivative.
Yeah.
So, if I plug in for the point 0, for y equals 0, x equals 0, what's my slope?
-2.
-2. So at the point at the origin, I'd have a slope of -2. Agreed?
Yeah.
So I'm just draw a little slopey line. What about the point 1, 1? What is my derivative? Put a 1 in here for x, 1 in here for y. What do I get? -1. So I'm going to draw a little slopey line at 1, 1.
Wait, but wouldn't it be different, like less steep?
Well, this is steeper than that one, isn't it?
Oh.
I gotta draw them less steep. Yeah. Yeah, if I want a picture of it, I gotta draw it less steep. That's in fact true. What about the point 0, 1? Well, I'll put a 1 in for x. Sorry, 1, 0. Let's do this point. 1, 0, right? So x is 1, y is 0. What do I get?
X
1.
is 0?
X is 1. X is 1, y is 0.
-1.
There, 1. I said it backwards, so that's not on you. What about if I choose a point 1, -1?
1, -1?
1, -1.
-1.
I get -1 as well. Hey, see a pattern for this row
Yeah, it's all the
or
same.
column? So let's go ahead and finish all those for -1. Okay. And then the next one, let's try, so knowing that pattern, let's take a look at 0, 1. 0, 1. If I put it 0, 1, what do I get? -2. So I'm going to point this down at 2 below.
You're just plugging the x, right? Not the one.
Well, there's no y, so there's nothing I can plug in there.
Is
But there will be y soon, and very soon. In fact, that's the reason why we're not going to be able to take the antiderivatives, because we're going to have a y where we don't want one.
What are these lines? What are these lines?
Well, I'm saying that at this point here, the slope would be in this direction towards -2, right? My
Oh, it's
slope
just
would be 2. So I'm
negative
just drawing
positive?
slopes. Well, I got a -2 slope, right? When I plug in 0, 0, I got a -2 slope. So I know if the function goes through this spot right here, it would have a slope of -2. So it'd be going this way. That's what my function would look like.
Okay.
Okay, so far so good? Okay, we're going to keep going. What about 2, 0?
0.
0. So my slope would be 0 here. What about the point 2, 1?
0.
0. So what about my point 2, 2?
0.
0. I see a pattern. I'm going to go ahead and fill out my pattern because I don't like being bored. What about the point 3, 0?
1.
1. Put your hand up. Okay.
It's cool, but
What about the point 0.31.
What?
What about 0.31?
1.
And then, so I've finally got the pattern down to a fine art. Now I'm going to look over here in negative land. 0, -1 gives me -3. My slope would be even steeper. I look down here, there's -3 right there, so I'm going to go like that. Sorry, I'm off by a ½ inch. -3, -3, -3, -3, -3. Now I need to go, this one's going to be -4. So I go 1, 2, 3, 4. So I'm aiming at that spot down there. Let's see if I can do it.
Oh, I get it. How is this?
And then I want to do, last one's going to be -5, right? Even steeper still.
I feel like this has something to do with
All right, so what was my goal, by the way, Hummer, when I started talking about this problem? I said, what if I didn't know how to find the integral to get that answer? What would I do? I want to get a picture of it so I can figure out what it looks like.
Correct.
What does this look like, Hummer? If this is a picture of what it looks like, what does it look like? Looks like a bunch of lines, except imagine you are starting, say, here. Which direction would this function go from there? It would go like this, really steeply down, and then it would get less steep, less steep, less steep, less steep, less steep, wouldn't it?
Wait, why?
Because these slopes are getting less steep. They get closer to this way, we know steeps are less steep. So it would look like that, wouldn't it? What if I were to choose, what if I choose 0.01? What if I start right here? What would it look like?
Go down to 1, 0.
It would go down like that,
Or no. Yeah.
that,
Oh, well, and then you go up.
and then up.
Wow.
What's that shape called, by the way? Oh, I gotta keep going. What's that shape called?
Concave.
That's true. What do we call it back in algebra 2?
Parabola.
Parabola.
Yes. So,
Isn't this a parabola?
X minus
So it's giving us, no, but the slope field tells us if I use this drawing method, what the original function looks like. Doesn't it?
Got it.
And if I were to go through the 0.00, it would instead look like, same thing, except it'd be under it by 1 the whole entire time. Okay? Now, there's always multiple answers for a slope field. Why? Because I don't know what the constants are. I don't have the constants, so I don't know which one I'm going through, right? But I can tell you what the function looks like. Agreed?
Couldn't we just do that by just doing it in
We can until we can't.
Why?
Okay?
Oh no.
Oh, wait, your graph should look like this, right? Flip it over. Take a look at number 2. Take a look at number 2. How do we integrate y with respect to x?
No.
I have no idea. Actually, I'm lying to you. Hold on. I have no idea either. So therefore, what are we going to do instead?
Draw it out.
We're going to draw it out and sketch it using this method. Got it?
So we do like.
So you're going to plug in values. You pick values. 0, 0. So on number 1, you would have 0, 0 would be 1. So you draw a slope in the direction of 1.
What do you mean in the direction of 1? So like if you're at 0, 0.
So you're at 0, 0.
Yeah. I get when it's not.
Here's the point, right? What the slope of the origin? It would be like this, right? You draw a little dash there, saying at that point, the slope would be in that direction.
And it's only not the same in this way if there's a y, right?
Right. Right. Now, they're all
It's like
I mean,
the x's
all of them are going to start developing that, but yes. Oh, wait, there's C5 and 6 at the bottom. Don't do those because I don't have a slope field for you. It's on the next page, which you never have. So just do 1 through 4. Fine, do this homework, and then we'll talk next time about how this could possibly help your life.
Can't possibly.